Welcome and thank you for joining us. I'm Tally Callahan, Linguistics PhD and Senior Business Operations Manager at Welo Data, and today's moderator. So at Welo Data, we specialize in delivering exceptional, high quality AI training data. Today, we're very excited to continue the discussion of our model assessment suite, our groundbreaking research tool designed to push the boundaries of causal reasoning in large language models. The mastery of causal reasoning, the ability to understand and predict cause and effect relationships, is really critical for LLMs to improve. Yet current models struggle when faced with novel, nonlinear reasoning tasks, especially in multilingual settings. Our benchmark seeks to address the current shortcomings of causal reasoning evaluation by testing for complex, nonlinear logic chains and incorporating domain specific, story based contextual reasoning tasks across 6 different languages. So, in our first webinar, we talked about why causal reasoning is such a critical yet challenging area for LLMs and our AI/ML team's unique approach to the evaluation framework. Today, in our second webinar, we'll be focusing on Welo Data's research lab's leadership role in mass and diving deep into the linguistic findings. To explore this further, today I'm joined by two of Welo Data's PhD linguists who spearheaded the development of the evaluation framework and analyzed its results. So we have Dr. Abigail Thornton, our research lab's lead. So Abigail led the research and development of the multilingual causal reasoning evaluation framework. And we're also joined by Dr. David Harper, who's our data scientist. He led the analysis on Max. Welcome and thank you so much for joining us today. We have several questions today. The first one we're going to dive into is for Abigail. So Abigail, how does your team's linguistic research complement the AI ML efforts in improving multilingual causal reasoning in LLMs?
Yeah, our team's linguistic research significantly enhances the AI/ML efforts in improving multilingual causal reasoning in large language models through our linguistic expertise and our extensive industry experience in natural language processing. Our linguists possess profound knowledge in various languages and dialects, enabling them to understand the nuanced syntactic, semantic, and pragmatic aspects of language. This expertise is crucial in designing and refining algorithms that can effectively interpret and generate text across multiple languages. Furthermore, our industry experience in NLP provides us with insights into real-world applications and challenges. We have worked on diverse projects ranging from machine translation to sentiment analysis to relationship extraction and more. This hands-on experience allows us to contribute practical insights and data-driven strategies to the AI/ML efforts, ensuring that the LLMs are robust, context-aware, and capable of handling complex causal reasoning tasks in multiple languages. So by integrating our linguistic research with cutting-edge AI/ML techniques, we help to enhance the model's ability to discern causal relationships within and across languages, leading to more accurate and reliable multilingual applications.
Awesome. Thanks so much, Abigail. So I think for the majority of the rest of our questions, we're going to be starting by diving into the methodology. Right. So we have a slide deck pulling up right now for the rest of our questions. So next question, also directed towards Abigail. We'll get to you soon, David. So Abigail, can you explain the methodology behind creating prompts for bilingual and cross-lingual evaluations and how that affects the outcomes?
Yeah, so one of the most important things about our data set is that it's completely novel. So the model's never seen this data before. Another important aspect of our data set is that it's all human generated, and we work with experts to create this data. So on the slide, we have an image of our pipeline for the data creation. So the pipeline starts with our domain experts, and we have our domain experts generate fact-based scenarios with causally related events. The scenarios then go to 2 separate pipelines. The first pipeline is a story writing pipeline where our writers who all have at least 5 years experience or advanced degrees, write stories based on the scenarios from the perspective of a participant involved in the scenario. The other pipeline running in parallel with the story writing pipeline is our question writing pipeline. Here are reasoning experts, so folks with advanced degrees and 5 years career experience in philosophy, linguistics, and NLP. They generate question and answer pairs about uh, the events in the scenario. These two pipelines then go to translation, and the English prompts also go to compilation. So while the English prompts are being compiled, they're also being translated by domain-specific translators who have experience within the domain of the generated scenario. The translators are asked to retain semantic equivalence of the original story or the original question instead of reverting to like a one-to-one translation. Then those prompts are compiled and we do evaluation on the whole data set. The result is then our prompts are very complex and we're evaluating the model's capability to extract the causal relationships from stories and be able to discern those relationships from the context of the story. So if we look at the next slide, we have an example of one prompt. So like I said, the prompts are very complex. There's basically 4 parts to each prompt. We have the introduction, which introduces the task and provides context for the model. And if there are any definitions that need to be provided, we provide them here. The next piece is the story. So here we provide that subjective story from the perspective of one of the participants from the scenario. And then the next part is the question. So here we have our causal reasoning question. We also provide answer instructions and we provide formatting instructions so that we're guiding the model on how to respond to the question, but also guiding it to respond in a consistent way across all the models we evaluate. The final part of the prompt are the options. We have 2 types of questions in this data set. We have binary questions. So here the options would just be yes or no. And we have multiple choice questions. So here the questions would have up to 10 different options. One of the key differentiators of our data set is that we're able to ask the same set of questions about the same story and the sets of stories from the same scenario. So in this particular slide, we have an example of 2 prompts from the same scenario. Here we're seeing 2 different stories, but we have the same question. And this is our causal discovery question. If we go to the next slide, we can then see how we leverage this type of approach by also using the same story and asking different questions about the same story. So again, we have one of the prompts from the previous slide, but in this table beside it, it shows all of the questions that we ask about the same story. So we ask causal discovery questions both in binary and multiple choice format. We ask questions about whether the model is able to identify a confounder appropriately. We also ask, we also provide the causal discovery question with different language variants. So we use different semantically weaker verbs, which have the same meaning in context. And then finally, we evaluate the model's ability to identify how likely a causal event aligns with the violation of a prescriptive norm. And this can be both implicit or explicit. And finally, we actually then extend that question and apply the language variation to that question as well. So it's a very comprehensive data set that allows us to identify not just the accuracy of the model in answering these questions, but also its consistency when asked in different ways or asked the same question about the same set of events, but from a different perspective.
And Abigail, just to make sure I'm understanding, you ask these 4 different categories of questions for every single story in every single language.
Yep. Yeah.
It's a lot of work, a lot of data that we're getting.
Yeah, it's a lot of data. And that's one of the beautiful pieces of the methodology is that we can really leverage our data set in that way.
Awesome. So next question also for you, Abigail, related to this. So how does all of this work build upon existing studies in multilingual AI and causal reasoning?
Yeah. So our work aims to improve the inconsistent performance of LLMs in reasoning tasks by addressing their lack of logic for complex multi-step reasoning problems. This builds on findings that current evaluations are broad and hinder improvements due to linguistic diversity and prompt complexity limitations. So, our methodology introduces these novel prompts that query causality in narrative documents that are subjective and written from the perspective of participants involved in objective, fact based events. This approach measures, again, the model's accuracy, but also its consistency in identifying causality across, again, like I said, the stories, the questions phrased in different ways, but also across the different languages. So this sets a new standard in multi-causal reasoning research. We also, previous research also shows that the training data tends to be repeated in the model outputs when evaluating causal reasoning. So by leveraging our human-generated data sets, we avoid the problem of the model already having seen the data and being trained on it, and we're able to actually test the causal reasoning capabilities of the model. And then also, we build upon existing studies by focusing on the causal reasoning capabilities of LLMs across multiple languages, addressing this gap where most of the causal reasoning benchmarks are very English-centric. So our approach involves human translated prompts and stories in languages with wide ranges of linguistic features and include Spanish, Japanese, Korean, Turkish, Standard Arabic, and most recently, French and German. So this slide here, we see an example of one of our English prompts. And the prompt next to it is the same exact prompt. It's in Spanish, so it's its counterpart. You see that the structure is exactly the same. The translation is semantically equivalent to the English prompt. With this approach, we have a very comprehensive evaluation of the model's ability to identify causality, discover areas of weakness in causal reasoning, and then again, compare the performance across multiple languages. We acknowledge the varying performance of multilingual models across different languages and observe that there's this urgent need for more complex causal reasoning evaluations, just in English, but also in these other languages. So our work aims to bridge this gap by providing a balanced representation of languages with varying linguistic features and resource availability. And then finally, our work addresses the challenges identified in the complexity of causal reasoning tasks. So by evaluating LLMs with more nuanced and contextually rich prompts, our goal is to overcome the limitations of traditional benchmarks that only assess these simple linear causal relationships. And we build on these previous insights by enhancing the model's ability to generalize causal understanding beyond these specific phrasings and linguistic variations. This ensures that our approach addresses the complexities involved in causal reasoning tasks. So in sum, our goal is to set a new standard in multilingual causal reasoning research by providing this deep and comprehensive evaluation that addresses the identified gaps in LLM causal reasoning performance. And this contributes to the broader objective of not just enhancing LLM's causal reasoning capabilities, but also the advancement of and development of AGI.
Awesome. And to kind of tie together some of the points that we have been hitting on so far. So we have these prompts on the screen right now. And I also remember when you were talking about our pipeline, you mentioned that translation was part of it. So could you just give us a bit of an understanding of how, with our methodology, with the two prompts that we see, what is it about our methodology that's special that we couldn't get from running the English prompt just through like an LLM to translate it into Spanish?
Yeah, so because our scenarios are domain specific, we recognize that there's domain specific jargon, domain specific nuances, and by working with translators who have experience in those domains, we're able to ensure that the translation is accurate and semantically equivalent because not only is it are they experienced in not only are they proficient in both languages, but they also have that background expertise to be able to accurately translate these complex domain specific concepts into the target language.
Got it. And again, to tie it all together, you were saying that this is all novel content. So we wouldn't necessarily expect an LLM that's very good at translating from English to Spanish, let's say, to have that domain expertise because this is all new.
Yep, absolutely.
Got it. Awesome. Cool. So let's move on to some more findings questions. And now we're finally getting to you, David. So, David, which languages emerged as the top performers in your monolingual causal reasoning evaluations? And why do you think they excelled?
Thanks for the question, Tally. Well, as expected, we find that not all languages perform equally well. We hypothesize that some of this is related to a model's resource availability, which Abigail mentioned previously. The vast majority of training data is in English, so it's no surprise that we see English here as a top performer. But we also see that Spanish and German also perform very well in our testing. As linguists, we do want to not just look at the accuracy, we want to think about what are some underlying factors that might be contributing to these accuracy metrics that we have here. So this is an area we hope to investigate further, but it is notable that the top 3 performing languages here have SVO word order, so subject, verb, object, word order. Japanese, Korean, and Turkish all have SOV word order, so subject, object, verb, word order. And finally, Arabic's dominant word order is VSO, so verb, subject, object. Only about 7% of the world's languages have dominant VSO word order. So this will be a word order that comes up pretty infrequently in our training data. And it may help to explain why some of the models struggled with Arabic. There are obviously other differences, many differences between the languages we studied in this experiment. For example, orthography, morphology, or some other things that we could be looking at, but we're going to leave those for our next talk.
Yeah. So yeah, David, that totally makes sense. It sounds like it's pretty clear what we're seeing in terms of top performers and bottom performers, when we're ranking their accuracy and the performance. So as we kind of turn to thinking about things bilingually, what are some of the key preliminary findings from your bilingual evaluations, and how do those compare to the monolingual results?
So first off, let's look at what we mean by bilingual prompts. So as Abigail mentioned, we have these different pieces to the prompt. We have an introduction, we have a story, we have questions, and then we have the options where the model selects yes or no or selects from the multiple choice options. We can rearrange these different pieces of the prompt using the different languages that we have translated into. So for example, we can have a language English to start off, then we can have Spanish, then we have a question and options in English. And we want to see what are the effects of rearranging these prompts into what we're calling a bilingual prompt. So we do think developers will be interested to see how their models are performing when we introduce multilingualism into the prompt structure. Let's look at our data first of all, and then we'll talk a little bit more about the results. So as Abigail mentioned, we do have a lot of data, but how much data do we actually have? So for question types, we have binary and multiple choice question types. The binary, as we mentioned, the options are yes or no. For all of our multiple choice questions, we're going to have 10 options to choose from. We investigated in this experiment 36 different language combinations. So we have 6 different languages. 6 times 6 is 36. We looked at 9 different models, and that means we collected over 630,000 responses from the models, almost 2,000 responses per language combination. So that's a lot of data to play with. And as a data scientist, I welcome this challenge. So what kind of results did we see? So if we look at the bilingual results, our first question was to see whether the accuracy degrades for the bilingual prompts. So as I mentioned, I think this is an interesting question for developers. Do the models perform as well with monolingual prompts when everything is either in Spanish or English or Turkish, or do they degrade when we start mixing the languages in the prompt? What we actually see is we ran our models we ran our prompts through 9 different models and analyzed the results. If we look at the aggregated results across all those different question types, we do not see much difference within the 9 individual models that we include here. So the bilingual results generally keep pace with the monolingual results. So our initial hypothesis was that we might see lower levels of performance for the bilingual prompts, but we don't see strong evidence of that here. In fact, we see pretty comparable results for both monolingual and bilingual. I think our results will get a little bit more interesting if we drill down into this data and look at performance by language combinations and question type. So in this heat map, we are looking at overall performance by language combinations. So we took the results from all 9 models and all 36 language combinations and put them in this heat map to begin to explore differences by language. First, let me orient you a little bit to this heat map. So we have a story in one language, and then we have a question that is asked in one of the 6 languages that we studied. So story language is indicated on the y-axis. So I'm sorry for the small font, but the top row is Arabic. And if you move down, we have English, Spanish, Japanese, Korean, and Turkish. So that's reading horizontally. Those are all the story languages. The question language is on the x-axis. So each column is a unique question language. This means that we have 36 possible story question combinations. Some of these are actually monolingual. So for example, in the upper left-hand corner, we have Arabic story and Arabic question. Now, when I look at this heat map, my eye is drawn to the fact that the colors seem to align vertically. In other words, the heat map shows consistent accuracy rates for question locale and less consistency on the story locale. The deviations here are relatively minor, but this seems to indicate that accuracy is influenced more by the question locale than the story locale. As to why this might be, we can point to something that has been studied extensively in cognitive science, namely recency bias. And in a paper from 2024, a couple of researchers from Dartmouth published this paper on serial position effects and how both primacy and recency effects are found in LLMs. We also find evidence here in our experiment in the way that models respond to our prompts. So some of the models are actually quite verbose. Some of them, they will give us the answer and that's it. Some of them they really want to provide us with an explanation. And when they choose to share their reasoning with us, they do it overwhelmingly in the question locale. So the last piece of the prompt that they see. So even if the story was in English, but the question was in Arabic, they will almost always answer in Arabic. So now tying this back to differences in accuracy by language that we discussed before, we saw earlier in our monolingual results that English and Spanish perform better. So we see that here also, but especially when the question, that last element in the prompt sequence, is asked in those languages. So this suggests to us that the order of the language matters in your prompt. So if you have a high-performing language as the last language in your sequence, your accuracy seems to be higher. All right, now I'd like to drill down a little bit more into this specific question type, one specific question type, to explore differences across languages and questions. So we have another heat map here. On this slide, we are looking at a particular question type, namely the causal discovery binary question type. So these are questions that have the structure, did X directly cause Y, yes or no? And for this question, I wanted to actually just look at our top 2 performing models because it was interesting how poorly they performed on this question in English. When normally, as we saw in the last slide, models perform much better in English. And that's true of studies across this space. And we also saw this same pattern in some of the other models that we studied, but seeing this pattern in the top models was especially interesting. Again, this slide looks similar to the last slide in that we see this clustering by question locale. So if you're looking vertically on this heat map. However, again, we see that English performs the worst. And this, again, contradicts what we see in most studies. Usually English, with its vast head start in training data, is going to outperform languages in almost any task. However, here it performs only somewhat better than chance. In fact, the monolingual English, where the story is in English and the question is in English, is the worst performing language combination at just 57% accuracy. This is a yes/no question. If the model was just going to guess, it would get 50% of these questions right. But here it's only getting 57%. Before I discuss why this might be, I'm going to highlight one other interesting detail from this study. For 95% of our causal discovery binary questions, the correct answer was yes. And for 5% of our questions, the correct answer was no. Now, when the correct answer was yes, the top two models only averaged 68% accuracy across all languages. When the correct answer was no, the top two models averaged 97% accuracy. So this raises a couple of interesting questions. First off, why does English do so poorly? And secondly, why is accuracy so much higher when the correct answer was no? And the answer to both questions may have a common cause. And we have a few hypotheses about this. And if you have hypotheses, we'd love to hear from you. So first, to the English question, why does English do so poorly on these binary questions? There is evidence from previous research that models are conservative when they're uncertain. As Abigail showed you, we have complex prompts. And when we have these complex prompts, we hypothesize that this may lead to some uncertainty, and therefore models are more likely to answer no. So we hypothesize that for English, this tendency may actually be amplified by the increase in training data. So more data translates to a more conservative LLM with a bias towards no. As to why accuracy is so much higher when the correct answer was no, it's a similar story. So prior research has shown that LLMs have this negative bias in binary decisions requiring complex reasoning. So this would help to explain why, when the correct answer was no, the models did a lot better than when the correct answer was yes. This, importantly, actually has some pretty important experiment design implications. So if you're designing experiments, this will be an important thing to consider. All right, Tally, I'm going to hand it back to you.
Yeah, no, thanks, David. Super interesting stuff. So this last question that we have here, when we're talking about the findings, is to Abigail. So Abigail, are there specific linguistic features or structures that pose greater difficulty for LLMs?
Yes. So LLMs exhibit inconsistent performance with complex novel prompts in English, as David showed. And we see much underperformance in languages such as Turkish and Arabic. But another thing that we see with the data is that there's also a high variability in accuracy across different languages. So one of the things we observed is that Japanese and Turkish, for example, have the highest variability in scores. So the performance of these languages is very model specific. We hypothesize that some of this is related to the training data. So what we've seen, and David has suggested, is that languages that are dominant in the training data and have SVO word order generally perform better. So when we refer to word order, we're talking about the grammatical subject and object, as well as the verb, the predicate. In the example, the dog chased the cat, the dog is our subject, chased is our verb, the cat is our object. But not all languages have this word order. So there are several different combinations of word orders, but the two that we looked at are the SOV, which is subject, object, verb. And the example here would be the dog, the cat chased, and also VSO, so verb, subject, object. So chased the dog, the cat. And as David suggested, the languages with SOV word order and VSO word order, so Turkish, Japanese, and Arabic, face more challenges, and we suspect that this is linked to resource availability. So as David said, the majority of the training data is English, but as we continue to look at the volume of training data in these other languages, it is significantly less. It is significantly less than English. So even though when the majority of the training data is in English, it tends to represent about 93% of the training data. So as you can imagine, the rest of the training data is dispersed across the rest of the languages. So another thing that we see here is that morphologically rich languages, especially those with complex inflectional morphology, tend to have lower performance. This is also contrasted with English, which is really not morphologically rich at all. So while most benchmarks are focused on English, this really limits the assessment of multilingual capabilities. And we really see that there's an urgent need for just more comprehensive and linguistically diverse training data sets that are more representative of not just other languages, but other word orders, other morphological systems. And we hypothesize that we can enhance LLM's causal reasoning capabilities just by providing additional multilingual causal reasoning data.
That makes a lot of sense. So, Abigail, to close us out here with our final question, again, kind of focusing on future research and implications, how do the evaluation results influence your future research directions in multilingual causal reasoning?
We're very, very excited about future research in this space. Primarily, we want to look at the impact of resource availability and its influence on word order and morphological complexity. We plan to continue to test other high resource languages with SVO word order to see if our results are borne out. So we've already done this with German, and we found that it's consistent with English and Spanish. But we also want to test less dominant word orders like SOV and VSO. And we want to see what the variability is in performance across those different word orders. And then finally, and we haven't really talked about this a lot, but we want to look more at the performance by language within domains. So we looked at domains holistically in our paper, but we want to look at it a bit more granularly and see what the variability is by language, by domain. So which languages are better in which domains, and how does that vary across the domains?
Well, it seems like there's a lot in store for research labs. I'm looking forward to seeing what comes next out of both of you. So thank you both so much for your participation and this awesome discussion today. For our audience, we put a link to our recent white paper in the comments section below. If you'd like to reach out to anyone on our team, David, Abigail, any of the AI ML folks that we interviewed in our last webinar with specific questions, please also comment below. And yes, thank you all so much.